Hi, Cara. Right, I'm going to do question 1 of the probability non-calculator. Right, looking at the dice, you've got if you took that net and made a dice up, 2 of the 6 sides would have a 3 on it, and then you've got 3 4s and a 1. So what that means is that the probability of rolling a 3 is going to equal 2 out of 6, which is the third. So that's our starting point. And then it says, find the probability of getting at least 1 3 in 4 rolls. So really all we're interested in is whether we get a 3 or whether we don't get a 3. So we don't, if we're going to draw a tree diagram, we could do, we could get a 1 or we could get a 4 or we could get a 3 and start doing 3 branches and then follow all those along. But it's going to get very complicated very quickly, and we don't really need it. If we start thinking about a tree diagram that, on the first roll would either give us a 3 or not a 3, just those two things. And the probability of a 3 is a third, and the probability of not getting a 3 is 2/3. And then we could do the next ones. We get a 3 again or not a 3, and a 3 and not a 3, and then we could keep on building it up. Now, for 4 rolls, it's going to give us a hideous tree, so we're not actually going to draw a tree diagram for this. But at least mentally we can have that in our heads. The second thing to think about here is that it's asking you for the probability of at least 1 3. Now, if you've got at least 1 3, 1 3, 2 3s, 3 3s, 4 3s, that means you haven't got no 3s all the way through. Okay, you haven't got not 3, not 3, not 3, not 3. So if we can work out just that probability, the probability of getting not 3, not 3, not 3, not 3, work out that probability, all the other probabilities must have at least 1 3 in. That's the only sort of option that hasn't got any 3s in. So we're going to try and work this out. We're going to say, right, what we want then is the probability of getting not 3, and then not 3, and then not 3, and then not 3 again. And that's really following this sort of line of the tree, isn't it? We get not 3, and then we get not 3 again, and we get not 3 again, and we get not 3 again. So we're going to get 2/3 times 2/3 times 2/3 times 2/3, so 4 times. So the probability of that happening, of getting not 3 4 times, would be 2 over 3 times itself 4 times, so to the power of 4. Right. Okay, fractions, but that's all right. We can do fractions, because look, we're saying 2/3 times 2/3 times 2/3 times 2/3, 2 times 2 times 2 times 2. 2 times 2 is 4, 8, 16. So the top would be 16, and the bottom would be 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 again 27, times 3 again 60 plus 21, 81. 81, marvellous, right. So the probability of getting no 3s at all is 16 over 81. So the probability of getting, should we do a cool wiggly line down here? I think we should. Look. Very nice, right. So the probability of getting at least 1 3, how neat is this going to be? Not very, I reckon. At least 1 3 is going to equal 1 minus the probability of getting no 3s, 16 over 81. And that's fairly easy to do, because if I start at 16, I'll count up to 81. 4 will get me to 20. Another 61 to get up to 81. So it's 61 plus 4, 65 over 81. Are we happy with that? 65 over 81. All right, so and that's going to be our answer for this one. So quick recap. We said the probability of getting a 3 was 1 over 3, because 2 of the 6 sides had a 3 on. We thought about it as being either getting a 3 or not getting a 3. And we said, right, okay, it's at least 1 3. So we turned the question around and we said, right, what if we didn't get any 3s at all? So we got no, we didn't get a 3, then we didn't get a 3, then we didn't get a 3, then we didn't get a 3. Well, that would be 2/3 times 2/3 times 2/3 times 2/3, which would be this, 16 over 81. If that's the probability of getting no 3s, then if I do 1 take away the probability of getting no 3s, then all the rest, the 65 over 81, must be the probability of getting something with at least one 3. Because if you haven't got no 3s, you've got at least one. And we've got the answer. Hope that's all right. If it's not, then let me know on just put a no on that spreadsheet, and I'll go a bit deeper into it for you. Okay.